Today, we're diving into the surprising science behind how our brains actually build lasting knowledge. And let me tell you, it's probably not how you think it works.
Come on, you've been there, right? You spend hours, maybe you pull an all-nighter, just buried in notes. You walk into that test feeling like you've got it all down, you ace it, and then, poof, a week later, it's like you never even studied. So what is going on? Well, it turns out this isn't some personal failing. It's not your fault at all. It's a fundamental feature of how our memory is wired. And it even has a name, the forgetting curve. It's this invisible force that just erases what we work so incredibly hard to learn.
So, to figure out how to learn better, we've got to start with why we forget in the first place. See, our brains are all about efficiency. If we don't use a piece of information, the brain kind of assumes it's not important. It just clears it out to make room for what's new and relevant. And this whole process is surprisingly predictable. Research shows this curve applies to all sorts of important knowledge. In fact, studies find that after just 1 year, students can lose about a third of what they learned in a course. And after 2 years, that loss can shoot up to 50%. It's a really steep drop.
So how do we fight back against this forgetting machine? Well, the common wisdom is pretty simple: repetition. Going back over information tells our brain, hey, pay attention, this is important, don't delete it. But that leads to a much bigger question. Are all types of repetition really created equal? To get to the bottom of that, we're going to dig into this really fascinating study from researchers at Radboud University. They put this exact idea to the test in a real-world classroom.
So here's the setup. They took 180 medical and biomedical students who had just wrapped up a super demanding anatomy course. The researchers then tracked them for 28 weeks. That's about 7 months, just to see how much they'd remember in the long run.
They split the students into 5 different groups. Group 1 was the control group. They got 0 review. None at all. The other 4 groups all revisited the material, but in totally different ways, ranging from what you might call passive learning, like just rewatching a lecture, all the way to really active stuff, like interactive quizzes and even hands-on work with actual anatomical specimens. Now, the hypothesis here seems like a no-brainer. For decades, educational research has told us that active, hands-on learning is way better than just passively listening to someone talk. So obviously, the researchers expected that hands-on group, Group 5, to blow everyone else out of the water. But that's not what happened.
All right, let's get to the results, because this is where the data revealed something that really challenges our basic ideas about what effective learning even looks like.
First, the basics. And this really shows the raw power of repetition. The group that got no review at all, they only remembered about 47% of the material. But the groups that did any kind of repetition at all, they retained 55%. That's a huge 8-point jump. So the biggest takeaway here is that doing something is way, way better than doing nothing.
But, okay, that brings us back to the million-dollar question. Was the super hands-on active group work any better than just, kicking back and rewatching a lecture? Did the cool interactive module beat out a simple test?
The answer was 0. A statistical 0. There was no significant difference, none, in long-term memory between any of the repetition groups. Just rewatching a lecture was just as effective as the hands-on group work. So what on earth is going on here? How could passive learning possibly be just as good as active?
Well, the answer lies in this powerful little cognitive bias called the fluency trap. It's this tricky illusion our minds create that makes us feel like we're learning effectively when we might not be learning much at all. And it's the key to understanding that wild result.
So at the heart of it is this idea called processing fluency, which is basically just how easy or difficult something feels to our brain. When info is presented clearly and smoothly, it feels easy to process. When a task requires a lot of struggle and effort, it feels hard. And our brain uses that feeling of ease as a mental shortcut to judge how well we're actually learning. And as the researchers Finn and Tauber put it, this feeling can be incredibly misleading. We fall into this trap where we mistake that easy-breezy feeling of processing for a signal that we're learning deeply. But they are absolutely not the same thing. Let's look at some real-world examples. Over on the left, you've got these fluent, easy-feeling activities, like casually rereading your notes or watching a polished lecture. They feel really productive, right? But they're often super passive. Now, on the right, you have activities that feel hard, trying to drag an answer out of your memory for a self-test, or trying to explain a concept to somebody else. These take real mental grunt work. They feel less productive, but it's that struggle that actually forges stronger memories. And that brings us right back to the anatomy study. The reason the active and passive groups perform the same is that both methods created this fluent, easy experience of just being re-exposed to the material. What really mattered was the simple act of repetition itself, not how active it felt to the students. They confused that easy feeling of recognizing information with the hard reality of actually learning it.
Okay, so knowing all this, how do we actually escape this fluency trap? How do we build knowledge that sticks around? How do we use this science to study smarter?
Here are 4 key strategies. First, repetition is mandatory. Period. The Radboud study proved it. Second, learn to distrust ease. If your study session feels totally effortless, that should be a little red flag that fluency might be tricking you. Third, embrace what scientists call desirable difficulties. You have to choose the harder path that forces your brain to retrieve information, like quizzing yourself instead of just rereading. That's struggle. That's where the real learning happens. And finally, space it out. Spaced practice, doing multiple short sessions over time, will always beat one long cram session for building durable, long-term memory.
And that leaves us with one last thought to chew on. We often chase that feeling of fluency because, it makes us feel competent and smart in the moment. But what if the real goal of learning isn't to feel smart at all? What if it's about embracing the struggle, getting comfortable with being challenged, and recognizing that it's the friction of that effort that actually forges knowledge that lasts?